All right. Hello and welcome to December 10th, wasmCloud community call. We've got 3 agenda items today, but also feel free to use the end of the time here to ask questions as we're going through stuff. The first thing that we're going to show is from Eric. He has a walkthrough that he's added to our docs to show how to use volume mounts for workloads. Take it away, Eric.
All right, do I have sharing powers? Let's see. And all right, so hopefully y'all can see the document here. This is in a this is in a PR that is up on GitHub right now, and this is covering utilizing external file system resources via WASI file system pre-opens and how we do that in wasmCloud v2, which is using a Kubernetes volume. So this doc is basically focused on walking you through the deployment side of that, but I want to kind of walk through it from beginning to end to get a sense of what this looks like in practice. So here is a pretty simple Rust component. Thanks to Lucas for helping me out with putting this together. But this is using standard Rust libraries for file system and our standard approach for HTTP with components. And this is just going to pull in data from an external file and return that in an HTTP response. So pretty simple component. How do we make that run with file system resources that we're using in a deployment on Kubernetes? With wasmCloud, that is going to look like first naming a volume and then specifying the target path for the file or directory on the host machine. We're going to do that in our host deployment. And then in our workload deployment, we'll add that volume and we'll have a matching path in the host deployment there for host path. And then we will add the volume mount under the local resources for a component. And here in this mount path field, we'll specify where the data is mounted inside of the component. So when we deploy that, got a local kind cluster running now. Here is our component running. And if we curl that, this returns a sample.txt file that we had loaded up with the volume mount. So pretty straightforward stuff. This is intended to be just a basic proof of concept that shows you how to work with this functionality in wasmCloud v2. We'll try and get this example that we've put together up somewhere in a wasmCloud repo where you can refer to it. But for now, you should see these docs coming in very soon, covering that deployment side of the story and helping you to do something similar for your own apps. Any questions?
Awesome. Thank you, Eric. And also super good docs. Actually, can I ask you to share one more time? I also linked to your next PR and ours for about services. And we merged that and that I also feel like let's call that the doc of the week. It's under overview workload services. Yeah. You want to talk a little bit about this one, Eric?
Sure thing. Ultimately, this is expanding on and trying to diagram the excellent presentation that Lucas gave the other week. But this is, if you want to refer back to that for kind of a personalized walkthrough, this is talking about services as the stateful companions to stateless components and the way they are going to function essentially as localhost and help to provide stateful functionality and TCP service for your workloads. And so this breaks down the communication flow, breaks down use cases, and attempts to give code examples and diagrams to help explain those where useful, along with some development considerations. Any questions there?
No, very cool.
Awesome.
Thank you, Eric. Yeah, I really appreciated that one with lots of diagrams. That was like one of the most probably the top requests to explain how services look and feel. And yeah, I think I almost feel like that one's like complete. I know docs are never complete, but we're getting close on some of these pages where it's definitely MVP. So thank you
Yeah,
for doing
we've
all that
definitely got
work.
plenty to expand on the development of services, right? And that's going to go under
Sure.
the wash section. But yeah, I think you're right for that overview section. We've got most of what I think we need at this stage.
Yeah, and actually I'm gonna jump the queue ahead of you, Lucas, on that one, just because it's relevant here. What we found is that right now, the way that we've configured Wash in our config and also for Wash Dev, right now it's geared towards being able to develop just a single component or a single service. And we want to make that flow work for being able to develop entire workloads. I wanted to have a full issue proposal before we got into this call, but I will get one up today that includes all my thoughts there. I've done a couple different prototypes, and I've got one that I really like that will be a way for you to change wash config so that it has your full workload definition. You can have multiple components and a service in it, and you can iterate on that service. Like if you're using the code example Eric showed there, a cron service that maybe every second triggers a component, you can do that locally. Is the goal of that change. So that's in progress, and that's my status update on that. Lucas, are you here? You are here. Would you like to talk through HTTP ingress?
Yes, let's do it. Moving things around. All right, so today we're gonna touch on a topic that has been discussed in the community a few times. The question is, how do I receive HTTP on my components? So when we're dealing with local development, pretty easy stuff, single host. When we're doing development for the Kubernetes cluster setup, once again, we bring up a single host, and that's fairly easy. You map a port externally to a single host, and off you go. But what happens when you have more than one wasmCloud host in your cluster? Where do you send HTTP? How does that work? How does it know where to go? So that's what I want to bring up here today, because there are many pitfalls, and the answer is essentially we don't know. There's no clear answer. There's more of a suggestion of what to do, but no clear answer. So we are looking to address that because we feel that HTTP is one of this ingress story for HTTP is one of the key deficiencies of uh, the Wasm Cloud project right now. And to do that, we need to talk. So, and getting to it, how do I change slides on this thing? Here. If we look at Wasm Cloud v1, this problem already existed there. So this is nothing new with Wasm Cloud v2. There's no such thing here that, well, seems like we're going to do something different in v2, therefore I'm going to go back to v1. If you decide to stay in v1, you also have that problem. You just don't know it yet because you probably don't have multiple hosts. The challenge here is if I have an application and I want to start an HTTP provider, I submit my application to Wasm. Wasm will place that on a host. How do I know which host to send HTTP request to? So this means that every time I deploy the application, that host might change, meaning your HTTP will stop working. And similarly, if you have two applications that need HTTP, each one declaring an HTTP provider, what happens if they both land on the same host? Well, we know what happens. One of them is going to get ejected. So it's not clear which one is the proper is the actual owner of that TCP port at that point, because it's basically failure in the placement uh, from a DEM side. So many things might happen here if you have two applications. They might land on different hosts, which means you're going to have two different hosts, two different TCP ports serving that application, and that's okay. However, if they land on the same host, you're going to have a problem. And every time you deploy any of these applications, you're going to have to go through that again. So it's not something that you can simply fix and move on. And the situation is pretty similar in V2. So V2 has the same problem. You can imagine that that's going to present itself there with a few different names because we don't use application, we use workloads, deployments, and so on. But the problem is there. You might have one application that is doing a rollout, going from workload A version 1 to workload A version 2. And initially, when you schedule the application, the workload landed on host 1. So you started sending your HTTP requests here. As soon as you roll out to version 2, the workload gets assigned to a new host. Now you have to send HTTP to the other host. And this is essentially a challenge that exists in Kubernetes and was handled using services, service endpoints, and so on. And that's a bit of what we're getting to here as a solution. But in this example here, is the same application trying to use the example.com host name and going to different hosts. Now, there's another problem, which I think is a bit more security oriented here, that you might have different teams, each one in their own Kubernetes namespace, creating a workload A and workload B. And they are both requesting the host example.com. Now, in this situation, first, why are they requesting the same host name? Who should be the actual owner? And the situation gets a bit more complex because the workload from this team might land on this host, the workload for this team on a different host. And now when you go to example.com, depending on the host that you are entering, you're going to get a different workload. So it's almost like a platform administrator nightmare. You have a little leprechaun going through your infrastructure and just rerouting all HTTP requests. And you can imagine the situation about deployments is also happens here. As soon as I deploy the workload A for this team here, it might actually land on host 2. And now you have the same host replying example.com differently depending on the request. So all of these are pretty challenging. And the answer here, how do we fix this, is really depends. If we look at what is the suggestion today, like how we instruct people to handle the situation in wasmCloud v1 and wasmCloud v2, is host spinning. What does that mean? If we look at the Helm chart we have in the WASH repository here for local development, we'll see that we declare 3 host groups, one called public ingress, one private ingress, and another one default. And the idea with these 3 host groups is that if you need to serve HTTP, if you need a component that serves HTTP, you place it in the public ingress. Therefore, that's the place that it's guaranteed that you can send requests and they will be fulfilled. The other 2 host groups here, one is for internal, meaning is exactly like the public, but is intended to not be placed on a public load balancer. And the default host groups is for those workloads that don't need HTTP ingress at all. They are not an HTTP server. So they are reacting to wasmCloud messaging. They are processing things via key value watchers. So they don't receive requests via HTTP. And this means that you are forced to always place your components in this public ingress host group in order to have HTTP. And this works. However, if you it's a very it starts to become a bit expensive in terms of containers because now we're supposed to use WebAssembly to pack more things, to pack more workloads on the same hardware. And here we are telling you to actually run more containers so you can do HTTP routing. So it defeats a bit of the purpose, but it works. The other angle is we can do intelligent HTTP routing, meaning we have something that receives the request for example.com, looks at the workloads we have deployed, and routes the request to those workloads appropriately. And this is a good one because and I got bitten by Firebase outage because my slide didn't update. But the intelligent HTTP routing here, this idea is essentially creating the ingress layer. So you have an intelligent HTTP server in front of everything that is capable of translating the host names coming from the client side to the correct host on the wasmCloud side. And this would fix the issue of knowing which host to send requests to. But we still have the issue of multiple workloads requesting the same host name. Should this be allowed? Should this not be allowed? And the answer again, it depends. And to get around that, one of the ideas is you don't route using the host name that the workload declared. You use the workload ID, which is a unique identifier for that component inside a given wasmCloud host. By doing this, if that component goes down, you know what, you're not susceptible to sending requests to a place that is not able to respond it because that workload ID is ephemeral. As soon as the workload is removed from the host, that workload ID will never be reused. So the other point here, which I was trying to do before it crashed, is use Kubernetes services. No, this is not the best option because the best option is this one. And using Kubernetes service is essentially, instead of giving you an intelligent HTTP router, we would replace the host name inside the workload with a service name in Kubernetes. And anytime that you add a new component, we would go to that service and add the component as a service endpoint. So essentially, we're forcing Kubernetes to be part of the HTTP routing strategy. And for that reason, thinking here that we really don't want to tie wasmCloud to Kubernetes, therefore, the best option is this one and not this one. Now, this is to give an overview of the problem that we have, the fact that it also exists in wasmCloud v1, and how can we solve it. So the proposal here is we're going to develop the ingress, which is an HTTP server that's going to sit in front of all wasmCloud hosts. And as we see the host name declared by workloads, for example, example.com, if we see this host name here on the ingress, we have information from the Kubernetes API about the host placement. Therefore, we know we have to route this request over to host 1 or host 2. And in this example here, it would look like we have a workload deployment here in this namespace. The first version was deployed, landed on host 1. We were sending requests there. As soon as workload version 2, revision 2 comes in, the Kubernetes API, which is the one holding all this state, is aware that this is not the correct placement anymore. And now we should be sending requests down to host 2. This means that in terms of outages and zero downtimes, the perception of rollouts from the client side is going to be totally transparent. So we are not incurring here any issues because we are controlling exactly when one workload moves away from a given host. When we are kicking off deployments, we're never removing the workload from this host here before guaranteeing that the new revision is up and healthy. Therefore, there's no situation here that you would get like a 404 500 because you are in the middle of deployment. And this is a fairly hard problem to actually solve, but here, because we have all this information already available to us, it's actually not that hard. And the question here to the community is more around the need and the approach here of introducing a new component to the wasmCloud cluster. With wasmCloud v1, we had WRPC providers, WADM, NATs, wasmCloud hosts, you name it. With wasmCloud v2, we have a runtime operator, NATs, and the host. So we don't have a very large number of binaries so far. And bringing in this ingress would pretty much add another service here to the baseline installation. However, I think just like NATs, this is going to be made optional because it's one of those things that you might actually bring your own. You might decide to look at some other information and use Istio, Envoy, you name it, but you have to build it yourself. So we're looking here from the angle that if you're trying out wasmCloud, you should get all the batteries included. So anything that we feel like you're going to need should be there from day one instead of forcing people to go write their own ingress. And that's everything. So not sure if anyone has ideas, but this is sort of the direction here that we're trying to go. And if you have any questions or any suggestions, pretty open to hear them. Frank, see your hand up.
Yeah, so I mean, FYI, what we do in our clusters, we force all traffic to come through an English controller. In this case, we use Contour, which is, using Envoy. And I think that makes sense. I mean, that clears up, let the switching between the different versions. I mean, we have a new component or even multiple routings and so forth. So it does make. I mean, I do appreciate this idea. I'm just wondering how you do the mapping between the unique ID of the deployment with the FQDN that you're going to have in front. And at some point, are you going to use a DNS or?
Awesome. Yeah. So right now in workload definition, we have the host name that you can pass on HTTP. And we also have the workload ID. The workload ID is generated by the host, and you can find that information on the workload CRD itself. So the ingress here, the job of the ingress is a Kubernetes cache, essentially, which has all the mapping of workload IDs to host name, and that is retrieved by connecting to the Kubernetes API and creating a watcher on the workload type. So this does not need to be baked into the runtime operator or anything. The information is already there. We would be consuming it from this HTTP gateway.
And from the point of view of, let's say, scalability, if you're going to be using, and since, suppose that your preferred methodology is actually to deploy this on Kubernetes, and suppose that you want to scale up, and you're going to be using different nodes. How you see this working?
Yeah, now we have 2 layers to scale. So you need to scale your wasmCloud hosts because you have more components. That will be one thing. If you need to scale your HTTP gateway deployment because now you have more HTTP requests going in and out, they are separate. So I see that we would have something like 50 wasmCloud hosts to 3 of these HTTP gateways. I think another point that you're bringing up here is how does this look like when you bring in an ingress, when you already have, like, I have Contour, I have Nginx, how would this look like? To Nginx Contour for the Ingress API, HTTP Gateway API, this wasmCloud gateway we're talking about is going to be a target. So you can still configure all your TLS information, your path routing in those ingresses. And when you telling the ingress where to send traffic to, you would say, send it to the wasmCloud HTTP gateway.
Which will be mapped to a service, right? Because
Correct.
from the HTTP proxy, we're going to go to a service.
Correct. And the most important thing here is we could be doing this directly on Kubernetes services by manipulating service endpoints. But we are proposing going in this direction just so we don't box wasmCloud installation to Kubernetes. Right now, only the operator needs to live inside Kubernetes. The hosts, they can actually live anywhere. And we want to keep that property because it's going to be really powerful for edge and IoT deployments.
No, definitely. Okay, thanks.
Awesome. Aditya has a question there, like the ratio. So ratio here is pretty much coming from the fact that if you look at HTTP load balancer installations, even I think AWS, if you go to AWS and get the previous version of load balancers, you can actually see how many load balancers Amazon is running for you. So just by looking at the number of IPs that are being returned in the host name. So we see HTTP proxying as a really CPU intensive but very efficient thing. And the three here, it's like you want more than one for failure and not a lot that you're just creating a lot. So three felt like, well, eyeballing essentially. Cool. And I also feel like because this is not actually forcing any change on the existing components, this is something that is being added on the side here without any changes to the existing code is a two-way door. So we can pretty much come here next week, take a look at how this HTTP gateway looks like. And if we like it, good. If we don't like it, we move it to the contrib directory. Right.
Lucas, I actually accidentally just muted you. My bad. That was me. But thank you for the presentation. I really appreciated it. Please talk more. Yeah, that's it for our agenda today. Do folks have other kind of questions or other items we want to talk about?
Well, I'm just thinking, I mean, like, since we have an open forum now, eventually, I mean, we could actually leverage eBPF with WebAssembly in terms of all the low-level routing. So that's something to be looked into the future.
Yeah, there's actually several different projects that are working on that in the space if you're interested. Euphoria, I think is what it's called, out of a Beijing university. Hey, you got it, Aditya. Thank you. You know Mia, so you did know it. I actually got to take that developer out, and she's really bright, and I know a lot of people are building on top of it now. Every once in a while when I'm floating around in the space, I see that pop up. I know Cisco did a prototype on some of this as well, and all of this is being able to run WebAssembly in essentially user space code in what would have otherwise been in the kernel space, and that's pretty cool. Now, is that the type of domain you were thinking about, Frank?
Yes.
Yeah, yeah, that's probably the project I would tell you to look at first. Now I know that Ben Titzer's group out of Carnegie Mellon are also doing some cool research in the space. I think they're very interested in finding cool ways to instrument WebAssembly, even if it's running at that layer. So if you're interested, you should probably talk to Ben and see what he's got cooking there. Anybody else have questions? All right. Well, we have a lot to do, like cutting a release candidate right now.
We're definitely waiting for that one.
There's a lot of people waiting on that one. Colin, did I see you come off mute? Were you gonna just say, yeah, me too? Because fair.
Oh, I don't know. I think right now it's most of my issues, assuming I need to import WebGPU into the WIT, which I think I do. It's just WIT bindgen stuff. Like you got like the basics working, but the WebGPU is like a very complicated WIT and things need to be put in the right order.
Yeah.
So it's a lot.
When you sent that message, I went and looked. We actually inside Wash. Actually, let me share that. Inside Wash, we have our examples there, and we have a WebGPU example now. Also, hey,
A
Lucas,
Rust, Rust one.
Yes. Yeah. But what you can see for what if you look at the WebGPU one, that's where it actually is using that specific version of binding. So we know that version aligns with this version of what we're embedding.
Yeah.
So yeah, you would have to go. This is where we're getting those bindings is from this crate. And if you go to that crate,
you don't put it in WIT.
we didn't, it is in WIT by somebody else. It's kind of like how you get those bindings from WStud.
Right. Okay, but is that available in C++?
It's a great question. I think what I would do is match what this what this was doing. So
okay, so you don't have it in the WIT bindings. All right, because the bindings didn't match what the WASI-GFX thing was. So I was like, oh well, it will match if I import the WIT file. So it matches, but it's just not generated in order.
Yeah, if you go to our world there, Billy,
yep.
to the wash one, and I think it's gonna be on the crate.
On
wash
wash.
crates, wash runtime with world. Yeah, it's not even here because it's coming from it's coming from
WGPU.
exactly, but it is being exported as WIT. So the graphics context, WebGPU handle interface, I can't remember exactly. They are there. This Rust code that we were showing before is pretty much shimming all of that, but the WIT interfaces are being exported by the host.
Yeah, no, I know it's on the host side. The problem is that, I don't know. It just yeah, I don't know. It's just the WIT, whatever the WIT is, even if we're not explicitly importing or exporting it, is different because the interfaces are different. So I'm just trying. That was the issue before. And I'm using all the right versions, so it's a little. I don't know. That's my whatever. That's my issue right now. But I think
we're gonna be able to get the release out in the next 30 minutes or so.
Yeah, I'm just using Wasm time at the moment because I couldn't define the wash config.json in a way that could get it running with wasmCloud. I don't know what that would be. So for C++. So that's it, I guess. But we'll continue on Slack. Once you get it out.
Yeah, well, yeah.
Time.
Right.
All right.
Thanks, Colin.
Hey, look us for the prototype of the ingress. Do you have any idea when you have something that we can play with?
Soon. Kind of half joking because this is something that been cooking for a while. and we have a pretty decent way to solve it. So we might have something by the end of the day as a pull request.
Okay. So once I get the new version, then I can try it out.
Yeah, sounds good.
All right, let's go do that. Thank you, everybody, for tuning in.